In this video, we're going to review the three types of methods to solve a system of equations. So the first up is solving by graphing. This is by far your easiest, but will really only work when you have a nice slope. Like here our slope is -2, here's our slope is -1, and if our answers come out to be whole numbers. If you have any inkling that it might get fraction answers, graphing is not a good option. But anyway, we're just going to graph our two lines. So y equals -2x minus 1. We got our y-intercept at -1 and a slope at -2. So I'm going to go down 2, right 1, down 2, right 1. Keep that pattern going. We can go up 2, left 1. Our next line, we have -1x plus 3. So y-intercept at 3. And we have a slope of -1. So we can go up 1, left 1. All right, and that's where our lines are going to intersect. You can keep it going down and to the right, but it's really kind of necessary. All right, and right there is where they intersect, and that's a point 1, 2, 3, 4. So -4, comma 7. So our solution is -4, 7. You could substitute them back in here. -2 times -4 is 8, minus 1 is 7, so you're good there. -1 times -4 is 4, and then 4 plus 3 is 7, so it works in both. So that's solving by graphing. Definitely the easiest method, not a lot of math involved, but again, it's only going to work if you have whole number answers. The next method is solving by substitution. With substitution, this is never fail method really. It's going to work all the time. Sometimes it becomes a little more cumbersome, but it'll work for any situation. So right now my second equation is solved for y. I have y equals x minus 4. So y and x minus 4 are the same thing. So I can take this x minus 4, substitute it in for y in that first equation. It's going to look like this. So that first equation stays the same. I still have the 2x, replace y with x minus 4 equals 5. Next up, we got to combine like terms. So 2x plus 1x is going to be 3x minus 4 equals 5. Add 4 to both sides. We get 3x equals 9. Divide both sides by 3. And we get x equals 3. But again, our goal in all these systems problems is to have an xy coordinate for our final answer. So we got to take this x equals 3, and we can substitute in for x in either of those first equations. I'm going to use this one because it's already solved for y. So y is going to equal 3 minus 4, which is -1. So my final answer is 3, -1. Again, you can substitute them back into the originals to make sure they work. Up here you got 6 minus 1 would be 5, and over here 3 minus 4 is -1. So we're good to go. So that's substitution. Again, substitution sometimes becomes more cumbersome, but it will work for any system that you get. And then last up is elimination. I think this one's the most fun. Works most of the time. I can't say it's foolproof like the substitution, but works pretty well. So here you're looking for opposites, okay? So you're looking at your coefficients, you're matching up your x's, you're matching up your y's. We got for their x's, we have a coefficient of 3 and a coefficient of -2. Positive, negative, but we could multiply this one by 2, this by 3 to have 6x and -6x. Or right here we have plus 3y plus 3y. If I multiply that second equation by -1, I can have a -3y, and then I'll have opposites. So that's what I'm going to do here. So the first equation is going to stay the same. 3x plus 3y equals 15. My second one, I'm going to multiply everything by -1. And then I'm going to add my equations together. So 3x and 2x is 5x. 3y minus 3y is 0. So we eliminated our y's. Now we're just left with 5x equals 20. 15 and 5 is 20. Divide both sides by 5. And I get x equals 4. So since we solved for our first variable there, you can substitute it back into either of these originals. It does not matter. I'm going to put it back in the first one. So I get 3 times 4 plus 3y equals 15. So 3 times 4 is 12. Subtract 12 from both sides. Again, we're just trying to solve for y here. And I get 3y equals 3. Divide by 3 and I get y equals 1. So my final answer is 4, 1. Alright, so those are your 3 methods for solving a system of equations. Go back and review all those. But that is the general idea of all 3 methods. Like I said, substitution will work for any of them. Elimination works for most. And really graphing, it's a nice visual representation of what a system is, where 2 lines intersect. It's an XY coordinate, your solution. But it'll only work really if you get whole numbers. It even gets tough, if it'd be like 1/2 or 3.5 or something like that. So just be aware of that as you review.